Today's lesson is called Absolute Value Functions Day 3. For the opening exercise, please graph the following functions using the appropriate domain. So you're going to graph f of x and g of x. Make sure you pay attention to the domains that are given to you. I would suggest you use your graphing calculator to create the table of values, and you are allowed to pick coordinates that would be easy for you to graph. Once you have graphed those two, you're going to answer the question underneath, what type of function do you see formed by your graph? And then you will be done with the opening exercise. At this time, pause the video and please try the exercise on your own and resume when ready to go over the answers. Okay, so you've tried the opening exercise. Let's go over the answers. In green, you will see my table of values for f of x. I was supposed to graph that function from -10 to 6, making sure to include -10 and 6. And you can see I wrote down the coordinates that would be nice to plot on the coordinate grid. All of those values came from the graphing calculator by going to the y equals screen, typing in the function, and writing down my values from the table. The purple is g of x. I did the same exact thing, and you can see them graphed on the graph to the right. Now, two things I'd like to point out that you need to add to your picture. Right here, make sure you make a note of the fact that there is no arrow. That's because it tells us to go from -10 to 6 only, not past that -10. On the other side, please circle that you do have an arrow. That's because they wanted you to graph g of x when x is greater than 6, so it's going to go on forever. If we were going to write this as a piecewise function, we'll come up with a new letter. We'll call it h of x. You'll use the large squiggle bracket, and you will write each piece with its domain to the right. So the first equation was -1/2 x plus 3. And we're going to use that from -10 is less than or equal to x is less than or equal to 6. The other function was 1/2 x minus 3. And we are going to use that for x is greater than 6. So that is what a piecewise function should look like when you write it. Example 1, identify the domain and range of the function, then write the appropriate function that matches the graph. This is an absolute value function which has two pieces, so we will take care of each piece separately. Keep in mind that you should be using y equals mx plus b as your format since these are linear pieces. Looking at section 1, I'll pick 2 points on the line to find the slope. I'm going down 2 to the right 1 using rise over run, and I end up down 2 as -2 over 1, which is equal to -2. So we'll call this function g of x. You're allowed to call it anything you'd like, any letter. And now we know that the number in front of x should be a -2 since that's the slope. We now need the y-intercept, so if I look right here, I can see it's crossing at 5. So I write +5 for my y-intercept. So now we have to tell the domain of where we're going to use it. If I look at this cutoff, this is x equals 2.5. We want to use that equation for anything less than that going this direction. So x is less than or equal to 2.5. Now when we look at piece 2, we will do the same thing. We have our 2 points. Here I would go up 2 to the right 1, which would be a slope of 2 over 1 or 2. So the 2 would go in front of the x. When I try to find my y-intercept, you cannot see it. So we're going to draw a little note here with an arrow going to this line saying you cannot see the y-intercept. So because of that, we have to have a method. One option, if this graph was larger, would be to take a ruler and extend the line to see where it crosses. Even once you do that, you might not be able to tell the exact coordinate. So you need to be able to do this algebraically. In order to do that, we need to use the slope of that particular line. So our slope is 2. And we need to pick 1 point off of the line to use. So I'm going to pick this point right here, which is 4, 3. That will be my m and therefore my x and my y. We are going to take and plug those things into y equals mx plus b, which is the setup for our equation of the line. We know y is 3 from the coordinate. We know the slope is 2 because we already found it. We know x is 4 from the coordinate, and we are looking for b. So 3 equals 2 times 4 is 8 plus b. I would need to subtract 8 from both sides to get my b value of -5. So now I can go back up and make this 2x minus 5 And again, if I'm looking at the domain, this time we're going to use it for numbers that are larger than 2.5. And we cannot include the 2.5 because we already included it up here. If we don't include it there, then we can include it in the second piece. Since it's already counted, we're going to do 2.5 is less than x. And then our upper bound actually has a stopping point since you see an open circle. So we're only going to use that up to, but not including 5. The last part of the question asks you to identify the domain and range. So the domain of our entire function, the highest x value that we have is this 5, and I go all the way over to the left after that. So my domain is x is less than 5, not including 5 because it's an open circle. And for my range, I don't have any values below 0 for y values. So y has to be greater than or equal to 0, but this time we include 0. At this time, if your teacher has given you a practice activity, you are done with this video, you can stop it and go do your other practice activity. If your teacher would like you to complete the practice within the notes, please pause the video, try the practice problems on your own, and then resume the video when you are ready to check your answers. In the top practice problem, absolute value function split into 2 pieces. Looking at section 1, I will identify 2 points to find my slope. So I would be going down 2 to the right 1. So that's a slope of negative 2 over 1 or negative 2. I'll call this function f of x. You can use any letter you'd like. And so we know a negative 2 goes in front of x for the slope. I cannot tell the y-intercept, but this is an example of one that I can extend. So if I were to extend this, I can see that it's crossing at negative 7. So my y-intercept is negative 7. I'm going to use that from this cutoff right here at x equals negative 2 and numbers less than that. So x is less than or equal to negative 2. In the second piece on the right, if I pick 2 points, I'm going up 2 to the right 1. So that's a slope of 2 over 1 or 2. That's going to go in front of the x. When I look to see where it crosses the y-axis, it crosses at 1, so plus 1. And we are going to use that for numbers that are larger than negative 2, but not including negative 2, since we already included it in the first piece. Our domain should be all real numbers because it's going to continue to go up and out with the arrows at the end. And our range should be y is greater than or equal to negative 3. There are no values below negative 3 for y. In the bottom left practice, again, we have 2 pieces. In the first piece, I'll pick 2 coordinates. I'm going down 2 to the right 1. So that's a slope of negative 2 over 1 or negative 2. So I will again use f of x. You can use any letter you'd like. We know that we're going to have a negative 2 in front of the x for slope. When I look to see where it crosses the y-axis, it crosses at 0. So I do not need to put plus 0. I just leave it. I am using that from negative 3, but not including it because it's an open circle. X is going to be sandwiched between that and then up to and including 0. I don't have to include 0 here, but if I include it here, I just have to remember not to include it in the second piece or vice versa. When I look at the second piece, I'm going up 2 to the right 1. So that's a slope of 2 over 1 or 2. So a positive 2 is going in front of the x for slope. It has the same y-intercept, so I don't have to put plus 0. And this time I'm using it for all numbers that are 0 and up. So x is greater than 0, not including the 0 since I already did. My domain, I'm only using x values that are greater than negative 3. From this circle and to the right, I'm allowed to use x values. When I look at the range, I don't have any numbers below 0. So y is greater than or equal to 0. Remember that when you're figuring out your domain and range, you can use the pinching strategy or highlighters to help you. Looking at the last one on the right, we have our 2 pieces. If I look at this first one, I have a point here and here. So I'm going down 3 to the right 1. So my slope would be negative 3 over 1 or negative 3. So I'll again use f of x. And I know a negative 3 has to go in front of my x. When I try to find the y-intercept, it's not showing on the picture. So I'm going to have to either extend this, and you can kind of tell here that if I went down 3 and to the right 1, I would cross at -1. But let me show you that by doing an algebraic example. I'm going to use this point, -2, 5. So -2, 5 is going to be my x and my y. And I already know that my slope is -3. So when y equals mx plus b, 5 in for y, -3 in for my slope, -2 from the coordinate in for x, and I'm solving for b. So 5 equals 6 plus b. I will subtract the 6 and see that b really is -1. I'm using that from this cutoff point, which for the first time is hard to tell. So I'm going to show you how we can find that exact location, because this is actually an x-intercept where it's crossing the x-axis. So in order to find the x-intercept, we are going to have to plug in y equals 0. So we know the equation is going to be -3x minus 1. And in f of x's place, you could have y. So in other words, we're going to use 0 in that spot, and then -3x minus 1. I would add 1 to both sides and get -3x equals 1. Divide both sides by -3, and I know that x equals -1/3. So if I'm going to say where we're using this, we're going to use it from, hard to see here, I'll just kind of erase that. So you saw that was a closed circle. We are going to use that from -2, less than or equal to x, less than or equal to -1/3. Now looking at the second piece, I'll pick 2 points. See, I'm going up 3 to the right 1. So this time I have a slope of 3. It's crossing the y-intercept at +1. So +1, and we are going to use that from -1/3, not including it because we already included it above, less than x, less than or equal to 2 because it was a filled-in circle that I covered right here. And so lastly, we need to identify the domain and the range. So if I look at the domain or x values, remember that those 2 circles, this one right here and this one right here, are filled in circles. We have the lowest x value of -2 and the highest x value of +2. So my domain is going to be from -2, less than or equal to x, less than or equal to 2. For our range, I see that my lowest y value is a 0, and since there are no arrows going up and out forever, I actually have to look at my highest y value that there is, which again is over here at this point, which the highest y value is 1, 2, 3, 4, 5, 6, 7. So here we can go 0 less than or equal to y is less than or equal to 7 for our range. And that concludes your lesson on absolute value functions, day 3.